Fusion Mobile, quality e-learning experience on the go.
You're welcome to today's class. We'll be discussing measures of dispersion. Okay. Alright. Measures of dispersion, they include number one, we have the range. Okay, and then we have the mean absolute deviation. Number two, the mean absolute deviation. And then number three, we have the variance, and we have the standard deviation. Alright, so we will have to define them, and then while we define them, we will carry out some examples. Alright, and we'll carry out one example for the group data and one for the ungrouped data. Okay. Alright, and so what we'll do here is take to the next slide. We'll start with the range. You have to know that there is a difference between the mid-range and the range. Right, the range is defined as the largest observation minus the lowest observation. The difference between the largest observation and the lowest observation. Okay. For example, if you are given observations like 2, 23, 20, 18, 27, 34, 30, and 24. Okay, define the range. Solution to find the range of this. Find the range of the given sample. Okay, so solution, all we have to do is to observe the samples very well and then pick out the largest number. Here is 34 minus the lowest number is 18. Okay, 34 minus 18 will give us a difference of 16. So therefore 16 is the range, which we said is the difference between the highest and the lowest number. The mean deviation, the mean absolute deviation, okay, it is the deviation of each observation from the sample mean without regards to the sign, without regard to the sign. Okay. Alright, the absolute mean deviation, the mean absolute deviation is equal to summation x minus x bar, okay, where x bar is the mean all over n. Here x stands for each sample, okay, and then x bar stands for the mean, the sample mean, okay, so the sample mean, and then n equal to the total number of observation. the number of observation. Alright, suppose we use the following numbers. For example, we are given this example 1 to find the mean absolute deviation. Find the mean absolute deviation. Okay, of the sample. This we have 25, 16, 26, 17, 11, 14, and we have 20, we have 15. Alright, so the best way to do this is to set up a table. And then find your mean, do the subtractions, and then form a total. Alright, look at what we're saying. The mean absolute deviation MAD is equal to the summation of x minus x bar, okay, all over n. Okay, we've defined all these things. Alright, but we can find x bar by summing all the numbers divided by n. Okay, summation of all numbers as 25 plus 16 plus 26 plus 17 plus 11 plus 14 plus 20 and plus 15. Okay, when you sum all the numbers, okay, and the n there is n is equal to 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. Alright, all over 8. Okay, and so x bar will give you 144 divided by 8, which is equal to 18. So x bar is equal to 18. And so to make things look neater, we form our tables. We have x bar, we have n. Okay, and so we form our tables. The first column stands for the x values. The second column will be for the x minus x bar values, and then the third column. So this will help us to do our computations easily. Alright, so on the first column we have our x6, the numbers we listed, and we have them as we have 25, we have 16, we have 26, 17, 11, 14, 20 and 15. Alright, so on the next column we have our x minus x bar, and so we have the absolute value of x minus x bar. Okay, and so remember that x bar is equal to 18. Yes, that's what we obtained x bar as. Okay, and so x minus x bar, we have 18 minus 25 to give you 7, 18 minus 16 minus 2 minus 26, 17 minus 18 minus 1, 11 minus 18 minus 7, 14 minus 18 minus 4, 20 minus 18 gives 2, and 15 minus 18 minus 3. And so the absolute value removes negative signs. Okay, the absolute value implies removing all the negative signs, and then we find their total. When you add 7 plus 2 plus 8 plus 1 plus 7 plus 4 plus 2 plus 3, alright, we'll find their total, and then summing them will give us 34. Okay, so therefore we can say that summation of x minus x bar is equal to 34. already we have n to be equal to 8. The total number of samples have 1, 2, 3. Okay, you can decide to number them to create a distinction too. Alright, you can decide to number them 1, 2, 3, 4, 5, 6, 7, and 8. Alright, so all we did was to number them, and so we have 5 and 6. Alright, so we have all the things we need to compute the MAD, the mean absolute deviation. Okay, because it is defined as summation x minus x bar all over n, and you can see the x minus x bar, and then summing it gives 34. And so therefore we can say that MAD is equal to summation x minus x bar, okay, all over n, which is equal to 34, and n is equal to 8. All right, so therefore MAD will be equal to, when we carry out that division, we have 4.25. all right, so we go into the next, the variance and the standard deviation, all right. Okay, we've made explanations on what we mean by group datas. All right, so the variance and the standard deviation. First of all, we'll explain these two measures as measures that do not involve absolute values. And you see here we had absolute values. Absolute values are positive values, they don't go negative. You can see from the table here we changed -2 to 2, and we changed -1 to 1, -7 to 7. Okay, so these are their absolute values, they are positive values. All right, so in variation and standard deviation in variance, we do not have absolute values. All right, some of the deviations from the samples could be negative, and then we can use the negative deviations. Okay, and if we don't want to use them, maybe the formula will help us know how to handle these negative values. But then your variance is given as is denoted as this symbol, and is given to be equal to summation of from 1 to the last value, to be summation d is equal to xi, each variable minus the sample mean x bar, all squared all over n. All right, just get this formula into your head, and then things will be a lot more easier for you. Then the standard deviation, I'll denote with xd, is equal to the square root of the variance. Okay, standard deviation is square root of variance, so which means we take square root of outcomes from the variance. All right, so we're going to determining that. So we use similar examples. Example 1, like the one we used above, where x values are equal to 25, 16, 26, 17, 11, 14, 20, and 15. All right, and we make a table because we have to find the standard deviation and variance. Find the variance and the standard deviation. All right, and for our solution, I'd like you to see how this works out. Solution for example 1, the variance itself, okay, is given as summation from the first value of x to the last value, and then we have x minus x bar being the sample mean, all squared all over n. Alright, and so we have to make tables again to accommodate x minus x bar, square x bar, then sum, and then divide by n. Alright, this time around we'll be having this table. Okay, having these tables with columns. Alright, am I sure it's more than this? Let me for the heading. And so this is the numbering. You have the first, the second, 4, 5, 6, 7, and 8. Okay, and let this be our x values. For x 25, 16, 26, 17, 11, 14, 20, and 15. And so the next will be x minus x bar, and so this will be x minus x bar squared. Alright, so how do we determine our x bar? X bar is equal to summation x all over n. Alright, and we already have x bar from the last example, x bar to be equal to 18. So x bar is equal to 18. Okay, you can as well check it out for yourself. And so we have 25 minus 18 to give you 7, minus 16 gives 2, minus 2 minus 26 8, minus 17 minus 1, 11 minus 18 will give minus 7, minus 14 gives minus 4, and 20 minus 18 gives 2. Meanwhile 15 minus 18 gives minus 3. If you square 7, you have 49. If you square 2, you have 4. The minus sign is going out because when you square a number minus 2, it's as good as saying minus 2 times minus 2. So the minus takes care of themselves, and then we have positive 4. Alright, if you square the number 8, we have 64. And if you square the number 1, we have 1. If you square 7, you have 49. If you square 4, you have 16. And if you square 2, you have 4. Square 3, you have 9. Alright, so these are the points we are looking for. So all we have to do is to add them to find their summation. Okay, so their summation is equal to adding them, and then which gives us 196. If you add 49 to 4, you add 4 to the outcome to 64. Just add all the numbers in that column, you will have 196. And so therefore, since we have summation of x minus x bar all squared to be 196, okay, and we have n to be equal to 8, we can find the variance. The variance is equal to summation of x bar minus x bar rather all over n, okay, minus x bar squared all over n, which is equal to 196. We have the value for this as 196 all over 8, and when you divide 196 by 8, you have that the variance is equal to 24.5. Now how do we find the standard deviation? The standard deviation is determined by taking the square root of the variance, okay, which we said is the square root of variance, okay, which is the square root of 5 squared, which is taking square root of our outcome 24.5. And when we do that, standard deviation xd will be equal to 4.95. Alright, you can punch that with your calculator. Alright, so with this we have come to the end of the study of measures of dispersions using ungrouped data. catch you up in the next class. Bye.